Okay, so we're gonna, uh, it's kind of a continuation really of 2.4, but it's partly 2.5 here. Um, so last time we ended with a particular problem. So we had an oven that at time 0 was at the temperature of 70 degrees Fahrenheit. And after 10 minutes, we had a temperature of 400 degrees Fahrenheit. And what we wanted to do was two things, assuming a constant rate of change. So we're assuming constant rate of change. What is it? What is the rate of change? And secondly, how long will it take to reach 500 degrees Fahrenheit? And for that, we're going to have to create an equation that models this process. So let's do part 1 first. Well, to find the rate of change, we do the change in the temperature, so 400 minus 70 divided by the change in time. So this is 330 degrees divided by the 10 minutes, and that's just 33 degrees Fahrenheit per minute. And that's also going to be essentially the slope of the line that we're going to use to model this equation. So we have a slope now. You can think of it as now for part 2, we have a slope which is 33 degrees per minute. We also have a point here. We're thinking of t as the independent variable. So we have a point 0, 70, right? Because at time 0, the temperature is 70. So we're thinking of t, capital T, as which is temperature, as a function of time. Okay, so if we wanted to actually graph this, at time 0, so here's little t, at time 0 we're at 70 here somewhere, so we have a point here, and at time 10 we're at 400 somewhere here, and we have a constant rate of change, so we know that our line is going to be something like this. That's how our temperature would grow, assuming you could grow forever. Of course, ovens usually have some limit, but let's just assume that the temperature can grow indefinitely. Then this is our line, and we effectively have a slope. We also have the y-intercept. So you can actually directly, let's use the point slope form just to be kosher here, but you can do y minus 70 equals 33 t minus 0. So y minus 70 is 33 t, and so y is 33 t plus 70, which is now the slope-intercept form. And this is going to help us to get the exact time when we reach 500 degrees. So now I'm going to rewrite this as the temperature at time t is 33 t plus 70. And what we need to do is we want to find how much time it takes to reach the 500 degrees. So I say, okay, I need to get the temperature to be 500 degrees, and I want to solve for time. So 500 minus 70, that's 430, is equal to 33t. And so t is going to be 430 divided by 33 minutes. And just to get that to be a little bit more tangible, 430 divided by 33, so that's approximately 13 minutes. Okay, so these are the kinds of problems that are in 2.5. They're based off of the concept of the rate of change from 2.4, but they're kind of really 2.4 and 2.5 are kind of just one big section. Let's do one last example of this kind of problem to end this video. So let's do one more example here. In this case, what we're going to do is we're going to give the rate of change. So suppose a tank of gasoline is being filled at a constant rate of, say, 2 gallons per minute. And the tank has a capacity of, think of like maybe an airplane or something, of 400 gallons, sorry, not gasolines, 400 gallons. If at time 0, the tank started with, say, 10 gallons, how long would it take to fill the tank? Okay, so this one I just gave you the rate of change here, too. And we also gave a maximum capacity here of how many gallons. So here now we'll think of a function, say capital G of t, the gallons that are there as a function of time t. And this is going to be some mt plus b. Here now we've already given you the rate of change, which corresponds to the slope. And we also have a point here that's 0 and 10. At time 0 we have 10 gallons, and that's exactly the y-intercept, so you can actually just directly write this as 2t plus 10. And the question is, how long does it take to fill the tank? Well, the tank has 400 gallons, so we simply write 400 is equal to 2t plus 10. So 2t is 390, subtracting 10. So t is, you divide both sides by 2, 390 divided by 2, so that's 1, 8, and 5 here. Just make sure, so t goes in 1s, 19, sorry, that's 195. There we go. Okay, so that's 195 minutes to fill the tank. Okay, so this is the end of 2.5. We will continue the next video starting 2.6.